Hello, guys. Hello, everyone. Today we have our online stream, our podcast, and where we talk about algorithms. But before we start, I'd like to introduce our guests. Yeah, we have two special guests. So, yeah, let's start from Nina. We have a Nina. Nina, can you tell something about you?
Yes, hi everyone. My name is Nina. I'm a front-end engineer in company Evolutions. I'm a front-end engineer, but I also like to solve algorithmic problems, and especially I like lead code. I've solved more than 400 problems on a lead code, and today I want to talk about algorithms.
Cool. Thank you very much. And we have also a special guest here. It's Artem.
Yes, hello everyone. My name is Artem, and I'm software engineer at EPAM company. In particular, I'm a iOS developer. Well, I have valuable experience with such project as application chat, marketplace chat, or sorry, marketplace application. And so now I'm working on the telecommunication project from Western Euro company. And of course, I like algorithms, but it wasn't be always sometimes ago. Well,
Okay, that's great that you like algorithms because I'm not a big fan of algorithms, and we'll talk about in different stuff regarding them, like do we need them? Um, okay, and maybe some background about your like algorithms life. I mean, when you did start doing it, why do you like it? Some like words about that. Yeah, Artem, maybe we can share it.
yes, it's a typical story for the for the typical developers. A couple of years ago, I tried to solve my first lead code task, and it was failed. I thought at that moment, well, I will solve it in 5 minutes. It's easy right now. It's funny now, but it wasn't funny there. Yes, and since that time, when I failed my first lead code task, I didn't like any resources like lead code, like HackerRank and any others. But some times ago, I got my first book about algorithms, which called Working Algorithms. I like this one. I think this is the nice book for the beginners. And so since that time, I can't stop until now. So that's the short story.
Okay, that sounds great. And yeah, the same question for you, Nina.
Well, I studied algorithms at the beginning in the university, but I didn't like it too much. And honestly, I didn't like these books. But maybe 2 years ago, I just solved some complex working task and I understood that I have some lack of knowledges in this sphere. And I decided to try some coding platform to solve something and just to see then. So I chose LeetCode because it has a pretty pretty nice white theme. And then I solved one task, then two tasks, then 10 tasks, and I understood that it is really interesting for me, and I just like it.
Okay, thank you guys very much. Actually, I didn't introduce myself. Uh, my name is Ivan. I'm engineering manager at EPAM. I'm also developer, and I did have some like algorithmic experience in my life when I was at school. We had some competitions, yeah, between schools and so on, and yeah, we was needed to do some algorithms tasks, and so I participated in a bunch of them. I wouldn't say that I was very successful. I did win something, but I was like a medium like player in this game. But after I entered university and then found the first job, I forgot about them because I maybe like till 5 times. I needed these algorithms during my professional work, and that's the thing we'll discuss today. Okay, I think yeah, we actually have a plan. We prepared, yeah, and we have a list of questions to you guys. I think we can start with the first one. The first question is: are algorithms and data structures mainstream from FAANG or MANGA, or it's established reality?
Or maybe both.
Yeah. Yeah, just a small context, maybe for those who didn't know that, like a lot of big companies in the world, they have an approach when they interview people. They like there are a lot of live coding, and the main part there is solving algorithm tasks, and they are not so easy as I know. I saw some interviews online. They are like I'd say hard, and before entering this job, you need to learn about algorithms a lot, and after that you'll be able to pass such interview. So yeah, the question is let's discuss this. What do you think about that?
I think that not only FAANG, but other smaller companies, they also take the example from the big corporations, and they also started to give such live coding interviews, and it works like sort of filter for candidates because many of these tasks they are hard and not everyone can solve them. So it just helps to find people who know something or who don't know something. What do you think, guys?
Tom?
Well, definitely I agree with Nina, and I would like to add that when you listen about the algorithms and data structures, 99% that you already think about big five companies, Facebook, Amazon, Apple, and so on. And in my opinion, this is the primary point because these big companies set trends for all tech world. And answering on your question and relying on my experience, I had some experience and with the interview process to some companies, and these some companies had the interview step as the process, and but the main point that it weren't be big five companies, and in my opinion, yes, it's already in the process of becoming as the needed step of the interview. I mean, algorithms is already a needed step into many companies.
Yeah, and we actually smoothly move into our second question about interview, actually, and having algorithms there. For me, I would like divide the interview into two different categories in terms of like live coding. The first one is live coding with kind of real life tasks, and the second one is algorithms. And when we're talking about algorithms, I mean something that you don't use a lot in real life. For example, like red black 3, some like write a quick sort from scratch, something like that. So what your opinion, like do need to have this interview or live coding will be enough?
It's an interesting question.
Yes, I can start. I solved like many problems on LeetCode, but I haven't found questions like really you need to solve this red black 3. Because it's like the more hard stage, and you can find it like when you optimize the hard problem solution. But you can also find more easy tasks on such coding platforms, and it will be useful for you not only on coding interviews but also in your real work.
Okay.
Yeah, I would say that it depends on your goal. I mean, in one hand, if your goal, your abstraction, yeah, if your goal is to pass the interview step, that's Yeah, that's obviously you need the algorithm just for it. And in the other hand, if you want to work on complicated distributed projects, implement difficult features, I do not know, maybe estimate and think about performance, like complexities, time or space complexities, then it's a little bit over than the step interview. And I suppose it's something bigger for you. You need it. Well, and I would say that it depends on your goal.
Okay, I have a point. Like from my point of view, like a general developer, like he or she doesn't need to know all like this deep stuff regarding algorithms. Maybe even graphs. It's okay if the person knows it, but if not, it's not a problem because in real life, it's not needed. So from your experience, probably you passed a lot of interviews. Yeah. So what the hardest task in terms of algorithms you received during the interview?
I hadn't got any interviews like live coding when I need to solve some tasks in front of my laptop. I hadn't got so lot of interviews. Like at Evil Martians, for example, we don't have such process for front-end engineers, and I think it's good because actually I think that for front-end engineer you really need to check different things, not like graphs and trees. I faced with such problems on my work, like trees and so on. But on interviews, I think it's not so necessary. Maybe if I made some compilers and sort of the thing, it should be more useful for me to know like hard algorithms. But I think for a general engineer, it depends on sphere, of course. You don't need really hard things, or you can just solve them for your own self-development.
Okay. What your experience?
Yes, as you said earlier, I agree that typically developer doesn't need a lot of knowledge about algorithms and data structures, and it's really true. And I would say that a lot of difficult things, a lot of difficult insights are already described in simple words. I mean, for example, if you want to learn about the Railback tree, maybe 10 years ago, maybe 15 years ago, it was a really difficult topic. But now we have a lot of examples, we have a lot of articles about it in simple words. And my primary point is in that you don't need to know everything, as you said earlier, and you just need the base knowledge. I don't know what is the time complexity, what is the space complexity, what is the binary tree, maybe. And yes, I would say that this is enough. What do you need?
Okay. Yeah, you can finish.
Yeah, relying on my experience, the algorithmic tasks wasn't really hard. I mean, this was the typical task from typical everyday. I mean, I don't know, concatenate two arrays, for example, or maybe map two arrays. I don't know. This is the typical task, and this is not about the Railback tree. This is not about the binary search. And I didn't encounter a Railback tree topic in the interview, in the really interview.
Yeah, that's the point. Like for my experience as well, I participated in a bunch of interviews to project to different companies. I had some algorithmic tasks, but they they weren't hard. Yeah, the hardest one probably was write the Fibonacci number, then a Fibonacci function, then do some optimization, minimization, other agents, and so on and so on. So I mean, it wasn't something really deep. It's something that I might solve during my work, but it seems like in manga companies, in Apple, Meta, and other Amazon, yeah, if we want to pass them through, we need to go like much deeper into algorithms. And like, what do you think? Why it's maybe needed? Yeah. Is it okay? Do you agree with that? Like, maybe they should also do the same interviews like other companies and give some real life tasks. So, what do you think about that?
Well, I would say that these companies have a lot of candidates, and this is like challenge. I mean, to choose the best one from a lot of people. I suppose this is about it. But of course, I'm not in. I don't work on such companies, and it's only my thoughts about it. Yeah, I think it's about it.
I heard opinion from some engineers from these companies that in real life they also don't need so often such algorithms, because when you need like some reliable project, you need some time-tested solutions and also readable solutions. And many solutions, like for algorithmic problems, they are not so easy readable. They are not maybe some time tested, but it is also a big important point. So I think it's, as I said previously, it's like a simple filter for such companies to test candidates, what they know, what they don't know. But I don't think that it really could check all knowledges in your sphere. And you also need some other filters if you want to choose this filter.
Yeah.
Yeah, sorry.
Yeah,
I would add that maybe if you are developing compiler, or maybe if you are working on databases, because as far as I know, such databases as Oracle, SQL uses B-tree as underlying data structure, and maybe if you are working on such companies, that I suppose that you need it, that you need this knowledge, maybe advanced knowledge, node-based knowledge. But typically, in my opinion, yes, it's really filter, and I I don't know how to think about it. It's just established reality.
yeah. And regarding the databases and all this like compiler stuff, you're absolutely you're absolutely right, and absolutely agree that there are a lot of spheres in software development and software engineering when you need to have this algorithms knowledge. Yeah, all databases, they have some indexes. You need to think how to store data optimizely. Actually, like, even in front end, when you do some hard like front end application, when you do some maps and something like that, you might have some complex business logic. So all of that sometimes requires having some algorithms knowledge. So okay, just to sum up and close this topic about like algorithms during interview. So that's okay to have like algorithms tasks, but easy algorithms tasks during the interview that you might face during the work, except cases when it's some specific like database position. And regarding these big companies, that's probably something we need because they need, because they have a lot of candidates. Yeah, something like that. So, and we agreed about the topic, and that's cool because I thought we'll have like the fight. You will be saying like, no, it's required to have deep algorithm knowledge, and we need to check it in the interview.
You know everything. Yeah.
Yeah. You mentioned one book when you were answering the question. Can you please provide information about the book and tell the name for our visitors?
This is in my opinion, of course, this is the pretty nice book. This is the book for the beginners. This book has a lot of simple examples, a lot of simple pictures. I mean, the difficult things, as I said earlier, described in simple words. And in my opinion, it's a really nice one for the beginners who want to learn something about it. For example, this book has such insights about space complexities, about mathematician models like linear time. Sorry, like
I
linear
don't
math
understand what you're saying, but
Yeah.
some clever words.
Yeah, and I would recommend every beginner.
Yeah, if you want to know all these words that he mentioned, you can read that book. What the name of this book?
Grokking algorithms, but I forgot the author.
Okay, we'll
name.
provide this information in
Grokking
probably you can
algorithms.
Google just Grokking the algorithms and
Yeah.
you'll find this book. I think it's the most popular book when we're talking
Yes.
about algorithms. So if you just Google like books for learning algorithms, that will be the first one.
Yes.
Yeah.
I also read this book and I also can recommend it, especially for the beginner level. And also I like the chapter that described dynamic programming. I think it's a really good chapter and it gives a good understanding of these principles. So yes, my recommendation too.
Yeah, when you said dynamic programming, I remember that's maybe the most, at least for me, the most interesting part of algorithms, because you need to figured out the solution. It's not something, okay, we need to use this formula or we need to use this approach. When you have dynamic algorithm task, you need to think maybe this way. So at least for me, maybe it's the most interesting topic in...
And more difficult.
Yes.
Yeah. Oh, okay, yeah. That's maybe
Agree.
the reason.
Yes.
Okay, I think it's enough talking about different companies and interview process. Let's talk about us as developers. And if I'm a developer and I'm thinking about like learning or not learning algorithms, I need to understand which advantages do we get from algorithms and studying these data structures and so on.
I can start.
Okay.
The first of all, I noticed that in 1 year of solving, I started solve tasks really faster. Because now when I just need to write like maybe something easy, but I don't need to like recall in my mind some method in my language or some simple algorithms, I can just write it automatically. And I also started to think more about different edge cases and so on, because it's not so cool when you received like wrong solution when you started to submit your solution on coding platform. And because of that, I started to think about some edge cases, about how some case can broke my code and sort of it. What about you?
Well, I would say that, as for me, the most primary advantage is a possibility to estimate and to solve your specific problem faster and better, simpler maybe. I would say that, in other words, for example, you can choose the best data structure between any others. For example, if you want to delete the minimum item every time, why not to use the priority queue, for example? You don't need the typical array, and any other simple examples. Well, and also I would say that this possibility allow you to think, as said my colleague, to think about performance, of course, because you can estimate how your algorithm, your function works now, how you can improve it. You can have a look at this, and you can understand what you can improve, what you can maybe how you can to less the memory usage, for example, and any other. And I suppose that this the primary point possibility.
Yeah, okay. Then I have maybe some proactive question about algorithms during your work. How many time having knowledge about algorithms and all that stuff help you to maybe improve the performance or I don't know decrease the risk that something will some problems with performance will have
Sorry, team, every day.
every day?
It's joke. No, not always, but I would say that often. You know, the person is, I mean, maybe for every developer, it's important to improve something. When you see at the code, when you see at the scope of code, you think, oh, I can improve it.
And
Yes,
refactor.
and refactor. Yes,
I wrote this code 1 week ago. Okay, it's too old now. I need to update it.
You understand. Yes, and maybe from this point, often.
Okay.
If we are talking about optimizing, I think it's about more like passive knowledge. It's not like, well, another working day, I will optimize something new. I think it works something differently. For example, when you start to solve some task, when you start to write some function, you automatically like think in your mind how you can do it more optimized, more clear, and better.
Mhm.
And so it's not like an active knowledge. In a front-end engineering, for example, we also haven't got like so lot of tasks when we are really optimizing something. But when we develop some new feature, we definitely need to use this also.
Okay, and then a bit deeper about that question. How do you think? Okay, we have so your front-end engineer, your iOS developer, and we can say that your front-end in terms of your developing the client.
Mhm.
I mean, if we divide developers into two parts, we'll have backend and client.
Mhm.
And in that case, you both are from client side.
Mhm.
Okay, you agree with that?
Yeah, yes.
Okay,
it's-
then we
it's
can
true.
then we can continue. And how do you think do like backend developers need to know about algorithms more, like regular backend developer, than regular client developer? It can be again a mobile developer, front end developer, desktop application developer.
Well, having generalized, I would say that every developer need to know just the base knowledge about it. Yes, if the developer wants to grow horizontally, to every time to learn something new. I mean, from my standpoint, it's nice to know how this data structure, how this algorithm works, as for the client developer, as for the backend developer. This is my standpoint.
Okay, so if we short it, so the answer is it doesn't matter. Both front end and back end developers should know like.
Yeah. Yes. From my standpoint, exactly. What I mean. Okay. The simple example. Imagine we have the one inner loop, and we have the array with 100 elements. It's a client side, and we need to go consequently from 0 to 99 index, and inside this inner loop we need to check every item of this array by its index, of course, on equivalent to the 0. This is pretty simple task, and for example, we can implement it in different approaches. But in my opinion, if the developer on client side understand how to decrease, for example, the memory usage, how to increase the performance, like time complexity, it's pretty nice, because if this developer will get the array with, for example, 1,000 or 10,000 elements, this algorithm will work pretty slow. And this is the client side. And from my standpoint, this is the typical example.
Okay.
I think maybe backend engineers need this kind of knowledge slightly more often, because I I often heard about my friends, backend developers, about like some more hard tasks that connected with optimizing algorithms and so on. On front end side, I think we also need, I agree, like basic knowledges, but also I faced with more complex tasks in my front end career, and it is also good to have some knowledges, because if you know how to solve easier tasks, you won't be afraid to take something harder. So it's also very useful for front-end engineers too.
Yeah, I'm asking because, for example, when we have some simple application, we have a backend, it's probably one server, and we might have like a lot of clients. It means that a lot of users, each user has its own phone, desktop, browser, and the client part will have kind of a lot of client parts. So it means in terms of performance that every user will have its own performance on his own device. And if we have a performance in one device, it will not affect another one. That's about the client. But on the backend, if we have performance issue, every user will be affected in that case. And that's like the first point that come up in my mind. Then, okay, so probably in backend we need to have not much, but a bit more. But otherwise, I saw like a lot of complex front-end applications. And here we have another problem that on front-end we have like relatively small amount of resources. I mean, the server is definitely much like better, has much more CPUs and so on. But on front end, we need to render 1 billion React components. We need to, download a lot of data. We need to render that. We need to think about fetching and so on. And we have like a small amount of like memory and CPU stuff. And I would say today, like it's my opinion that today it maybe that difference between front-end knowledge of algorithms and back-end necessary knowledge, it's almost the same. Like in general, sometimes of course the backend might more complex, the front-end as well or less. But I think that today maybe each developer should know about algorithms and DS at least at base level. Okay, and the question is, what is base level? Previously, we discussed that every developer should know, like algorithms, yes, it will help you to optimize. What's like should every developer know? And like the base level, what algorithms, what data structures?
Maybe I can say that idea to write your own sort function without invoke sorting in your own language shouldn't be freak out you. It's like I think you really need to know something basic sorting algorithms like merge sort, quick sort, and understand slightly how it works. So like it's not something black and unknown.
Yeah, can we stop at this point about sort? Because for me, I'm a developer. Yeah, I do something. I use sort function and I forget about sorting. Why do I need to know, like, for example, the merge approach or quick sort?
Because sometimes it may be useful to write like your own sort function when it's like sort of complex case, when you cannot just sort like in descending or ascending order, and you need to use some other parameters. So in this case, you need to slightly understand how it works like deeper.
Mm-hmm.
So, and if you understand also the complexity connected with speed and space, you can also understand what is good to use and what is not to use.
And how often, I mean, regarding this merge sort, how often like regular developer should might have such task when he needs to think about different sort algorithms. Because from my experience, I didn't have such. I had such experience during the interview. The only case when I was needed to think, okay, here probably the regular sort will not go because we have less amount of resources. It's better to go like this custom sort, because my opinion that sorting, maybe it's not something every developer should know in details.
It depends really, because sometimes like development process and maybe your backend engineers are not managed to do all features in the right time, and you need to do something on the client side, maybe temporary, like, and for example, you need to realize a sort on your own, and for example, it's not so easy like descending or ascending order, but you need to prioritize some elements by parameters that stored in other object. So it really depends. I think you cannot face it with such task for a long time, maybe. But when you faced, you may want it to solve it quickly and like understand what you do and what's going on.
Yeah, I get the point. Okay, you said like sorting. Yeah, what else about like the baseline for developer about algorithms?
I think maybe trees. What do you think about it? Like the very easy level of binary trees with left and right child.
When I hear trees, it's a bit fear for me, because when I hear trees, I think, okay, it's something complex, and I'm not clever enough to know about trees. Okay, trees. Yeah. Okay, I'll go to another room. I don't need this offer. I don't need this company.
Yeah. I would say that data structure is not important, maybe from my standpoint, of course, because if you need to, of course, it's nice to know if you know the binary tree, the base principle about binary tree, how it works, and maybe how to implement it. It's nice. It's pretty nice. But I would say that from my standpoint, the baseline is the understanding of complexities, space and time, of course. How to estimate it. I mean, you need to understand how to find the base operation by which you can understand which math module do you have. Of course, and I would say that's all, because if you know this base area, from my standpoint, it's enough in order to solve your first lead code, for example, tasks, maybe to estimate your first algorithm in production code. Yes, and if you know this, then I would say that yes, you can touch something deeper, like data structures, trees. I don't know, red-black tree maybe, but first of all, I would say that binary tree, red-black tree, some later.
When I hear red-black tree, I'm just starting crying, because it's something I have no idea what's that. Okay, do you want to add something to like base pack for developer?
Yes, I really agree with that point that it's really very useful, and you need to know how to estimate and measure the complexity of space and time, because, for example, lead code, it has a very useless metric like the speed of solution as a task. It beats 99%, and it's completely useless because it runs on the servers and it's completely unreliable, and you really need to know how to just understand this big O.
Yeah, and for like lead code tasks, they probably have a list of test cases with small numbers, medium numbers, large numbers. And okay, if you beat like 70%, it means that in most cases, your solution will work good. But in real life, when you create some solution, if you don't understand the complexity part, you can benchmark it, give like 10 elements, 100 elements. Okay, that's fine. It works. Perfect. And tomorrow you will have 1,000 element. And since the complexity is not linear or it's like, I don't know, n square or something like that, you'll get the error like, okay, Stack Overflow, thank you very much. The Google Chrome is going to dead. Yeah. So that's why I think this measurement is like the basic knowledge you need to understand before learning like next algorithms. About data structures, I think that developers should know data structures. You said that no, that they don't need to know it. Mm-hmm. What do you think?
I think mostly yes. Maybe not red, black trees, for example, but I think like in the front-end side, I usually realize some functions with maps and sets, different sort of arrays like that. Also, I sometimes need linked lists and trees. I think for the beginning, it's enough.
Yeah, and probably if you want to optimize your task, you need to just use hash map.
Yes.
Yeah, because there is actually a meme that during the interview, to manga companies, when there is a task, you need to say, okay, I will use hash map, and probably it's the answer, because in most cases, it really helps.
Yeah, but the big problem that in such companies like for Facebook, Apple, they require that you write your own map. I mean, it's nice. It's pretty nice if you can write, for example, your own dictionary or map function, because then they can see that you understand how it works, and you can understand, and they understand that you know it and that you know such topics. And as far as I know, of course.
Yeah, I had a similar situation in one interview. The interviewer asked me to write some maybe optimization for Fibonacci it was. And he said, okay, why do you think it's optimization? I used map. I said, okay, because the complexity of getting elements from map, it's 1. He said, why? I said, because it's like hash map. He said, why does hash map so fast? I said, okay, because there is a hash function. He said, okay, why? And we like getting deeper and deeper. And some point of time, he said, okay, we have a memory. We have some like indexes in this memory. How does it work? How can this understand? And at some point of time, I said, okay, I don't know, like give me the answer. I have no idea. So I didn't think about that. So because I was thinking about map and all this stuff on high level, but when we get in deeper and deeper to how these things works in computer, it actually was really interesting for me. Of course, it's not something you need to know, but that's something really interesting and maybe gets you a bit more understanding about these processes and all that stuff. And having such tasks, it's nice challenge, I would say.
Yeah, of course.
I solved some tasks like this on LeetCode when you need to design your own data structure and not use like some methods in your language. And it's not so hard when you like try it not on job interview. It could be really interesting. And yes.
Yeah, job interview gets your additional stress.
Yes.
And it's okay when you know the solution, but when you don't know, you need to think about that. And it takes time. It's like maybe 2 minutes without any word on the interview. And it's like not really, I for example, for me, I wasn't really calm during this time because I'm thinking I need to solve it fast, but he is like looking at me. Maybe I need to say the answer. And it was during like a couple of minutes. And at some point I realized, okay, I didn't think about the task at all. Okay, what should we do here? Yeah, so that's another problem about interviews. Okay, we discussed about the starter pack for developers, but a lot of time we named red black trees and so on. So how do you think is red black binary search tree horror and fear from the past? So to short this red black binary search tree, we can say just BST.
Yeah, I would say that first of all, before we get into it, I would say that I didn't encounter such topic, as I said earlier in the interview. And I don't know, maybe some way it's required. For example, for the compiler developers, maybe it's required, but I'm not sure on it. And I would say that it would be better to know the classical binary tree data structure than, for example, red black tree. But it's too nice if you know the base principles of red black tree, how to implement it, how it's work, and so on. And but you need also to understand the base difference between them. And the primary point is in that red black tree is one of the oldest data structures, tree data structures, which was invented in 1970s. And it's one of the first, as far as I know, self-balanced trees. I mean, it can support the balance dynamically, and by it works faster than, for example, the classical binary tree. Well, and I would say that that it's maybe from the past, but if you know how it works, if you know how to implement it, it's pretty nice for you as for the developer, because, as I said earlier, you're growing horizontally, and you maybe can apply it maybe sometimes in your production code or in the interview. But as I said earlier, I didn't encounter such topic. Yes.
Okay, what do you think?
Yes, I agree that it's very nice to know the purpose why we need some data structure. Not just we have these trees, I will solve them. Because yes, it could be an error if you didn't solve like simple trees or simple binary trees, and then you just go to the red black tree and you will say what the horror is it. But if you already have some experience in the field of trees, it will be okay for you. You can just ask the questions, why this type of trees is cool to use, not like AVL trees, why not them? They're also balanced and so on. So it's really important to understand the purpose when you need some data structure to learn.
And yeah.
I would add to that red black tree, as said my colleague, work faster than classical binary tree. And if you understand, for example, your goal, your specific problem correctly, then you can choose between other trees, because the world knows a lot of them. I don't know everything from them. Yes, and for example, the red black tree works faster in the worst scenario. It has, as far as I know, 2 log n math model. And the classical binary tree has, as far as I know, the linear math model, and this is the big difference. Yes, for you, for us, for the developer. Well, and if you need to implement such features, which require this data structure, that of course you need to know it, and you need. And maybe it's a horror and fear for you, but you need it.
It is, yeah.
Yes.
Okay, I have some more questions about binary trees, but to be honest, I don't understand the question. Maybe help me. Why is the red black BST still so popular DS of implementing symbol table DS? So first of all, let's clarify what is symbol table.
it's an data structure, and maybe in general it's an abstract data structure. I mean, in data structures and algorithm science, the one data structure can based on another data structures. And in simple words, it's an abstract data structure like dictionary in
Okay.
Swift programming language. I don't know how in JavaScript.
Maybe
Dictionary.
it's just map, hash map,
Maybe.
like when we
don't-
have some key and some value.
Yes, key value pair.
Okay.
Yes. It's an
Now,
abstract.
yeah. So to simplify it, we can say like map, hash map, because
Yeah.
it's more maybe general word.
Yeah.
Okay. And why like red black BST is still so popular of implementing this kind of data structure?
Ooh, I would say that because it's one of the oldest trees, the one point, and the second point because a lot of people already studied it. Really, I mean, if you Google, if you will Google, for example, the red black tree, and for example the AVL tree and splash tree, I don't know, binary tree, a lot of examples, a lot of information you will get about the red black tree because it's one of the oldest, because it has a lot of implementation examples, it has a lot of descriptions. I suppose this is the primary point because, as I said earlier, this data structure was the one of the oldest, and it's discover a lot of books. It discover a lot of topics, and for example, this data structure until now uses in Java, in C++, and any other programming languages.
Yes, and also if I remember well, this data structure has one of the best speed if you need often such operations like insertion and delete. For example, I know that for AVL trees, it's good to use them when you more often need like just to read some values. So red-black trees are better for this purpose, to not just read.
Yes, it depends on your goal. But I would add that if you have a lot of input data, like in backend, like 1 million, for example, or maybe more, then this data structure isn't good for this purpose.
Because it consumes a lot of memory, yeah?
Yes. No. Because it has it has a big height of tree, and your search will perform, for example, slower than the B tree search. B tree is a name; it's not an abbreviation. Well, and as said my colleague, you need to understand which your goal, which your purpose, and use for it. For example, in the client side, the red-black tree, in my opinion, is a nice one. For the backend, maybe not.
Okay, so from what I understand, the red-black tree is something interesting, and sometimes it's like worse to use it. Okay, and the next question, part of the question I still don't understand is, are red-black BST and 233 the same DSS? I mean, data structures. Yeah, first of all, what is 233? What's that?
It's sort of data structure. It's like some types of trees. We can also include in this question like 2, 3, 4 trees. When you have like 2 fields and 3 childs, or like 3 fields and 4 childs, and something like that. But in most of languages, there is a complex theme to implement such trees because we need like some pointers and so on. And yes, there are isomorphic trees, like we can map red-black trees to the 2, 3, 4 tree with the same structure. And yes, it's probably easier to implement red-black trees in many of languages.
Yes, I agree absolutely. I would say that The red black tree was invented based on 233, and these two data structures may be almost the same, of course. And 233 is the oldest version. Red black tree, in simple words, is the most simpler, more maybe modern version. And you can imagine red black tree just by collapsing red links into the 233. It's really the same data structures, the same from one side. Of course, from another side, it's another data structure, but very similar on each other. Yes, and I would say that typically, if you try to find some information about trees. As I said earlier, a lot of examples will be with the red black tree than, for example, 233, because 233 was invented in 1916s or 1970s. I forgot. It's too old.
Okay, I think we talked a lot about red black trees, and I have some. Actually, we finished with our plan and our questions, but I have a bunch more of them. During our conversation, you mentioned some algorithms, and you said like, okay, this one was invented in 1980 and so on. What the most modern algorithm? I mean, all algorithms that I've heard, they were invented more than 20 years ago, and they are like too old. Do we have something new, something popular that are invented, I don't know, maybe 5 years ago, 10 years ago, yesterday? Maybe you invented something, maybe you have your own algorithm.
I don't know what to say. I would agree with you, yes, that that a lot of data structures and algorithms were invented in the previous century.
Yeah.
Yes, and I don't know any modern. Maybe you know. I don't.
I know that many certain algorithms are improving today also. For example, in JavaScript, like this thought method, it was many implementations of this certain algorithms, depends on browser, but in most cases we had team sort. It's like improving certain algorithm, something like quick sort and merge sort. Merge sort and insertion sort. So it definitely appears in this century, and it's like a modern version, and it works really faster. So mathematics and developers, they are working in these centuries on data structures and algorithms too.
Yeah, because so you're a front-end developer, you work with JavaScript, and you know that you can, I don't know, imagine any word, for example, like, I don't know, React, and it means that you can add JS to this word, and there is such framework. Yeah, a lot of different frameworks, and in JavaScript world, every year we have a new framework, a much better and much faster, and so on. But when we're talking about algorithms, like when I started, during my career, nothing new on interviews. It means that that's something very basic, and maybe it helped people who are going to learn it to understand that you learn it once, and it will give you a very wide like knowledge and will help you in future, and that's so basic knowledge that you will not be needed to of course you can dive deeper to some different specific topics, but in general it's there is like some basic, you learn it and now you understand the whole picture what's going on. Okay, and another question I have, what your maybe the hardest topic in algorithms that you've tried, that you've learned, maybe that you haven't learned yet because it's so hard?
We mentioned dynamic programming because yes, it's really sort of not just what you can just learn and that's all, but it's a whole approach that you need to understand, and sometimes you don't know how to just take this task and take the right view on it, because it's like a complex approach.
For me, the last one was 2.3G and the Red Black G, the classical implementation. I mean, in terms of implementation, not terms how it works in terms of implementation, how to implement in this by yourself. And in my yes, the last it was the last difficult thing for my understanding. Yes.
Okay, for me is of course everything connected to trees and all that stuff. I know basics, but 2-3 trees and so on, it's hard. But I also heard some maybe Dextra or something like that. It's the name of the person. He created some method, and that's something that I remember. Okay, I understand it, but it's hard, and the next day I just forgot about that. So for me, it may be Dextra method or algorithm. I don't remember exactly. Okay, cool. And I think the last question from my side about maybe tasks. Can you maybe remember the most interesting algorithmic task that you have, that you, after solving it, you enjoyed a lot or something like that?
I remember one. Well, I was working on auto building network maps for data centers. And in data centers, there usually can be a lot of devices, like thousands, and there can be many levels between them, many hard connections. And the part of front-end side was to visualize this like graph with all this connection very clearly, and to also consider different cases when it could be really difficult and many connections. And yes, this knowledge is very useful.
Okay.
From my side, it was the chat when we implemented the chat feature in our application, and it was required a lot of difficult logic, like sorting, like concatenation, and many others. And we need to follow the chat in real time, like observers, like reactive programming, and then others. And in this case, in terms of this case, we need to think about performance, about how many times we are sorting our arrays, how many times we are concatenate our arrays, and so on. And from this side, we thought a lot about the time complexities, about the space complexities. But we, of course, don't create any famous algorithms and data structures like BT and any others. We just think about performance, as we had talked before.
Yeah, that's interesting. When I asked this question, you mentioned not something from lead code, you mentioned something from real life. That's the point. Like the most interesting and not maybe complex, but yeah, interesting algorithm task that you might face is probably will be in your professional life, not in lead code or HackerRank. Okay, I think we can finish here. Thank you guys very much for coming, and yeah, thank you for watching it. I hope you enjoy it, and maybe it helped you to understand something regarding algorithms. Yeah, I think that's it. Yeah, maybe you want to say something to our visitors or watchers.
Thank you for watching. It was a great pleasure for me.
Yeah, thank you guys for coming. And guys, learn algorithms. It's interesting, and yeah, it might help you. Thank you. Goodbye.
Thank you. Bye.
Okay, it was.